Okay, we're going to do 2.1. And the number 3 was asked about, and it says, what's the domain of the variable in this? Well, a fraction can have 0 as a numerator, like 0 halves is 0 or 0 thirds or whatever. The numerator can be 0, but 2 divided by 0, how many zeros does it take to make 2? That can't be done. So you never want the denominator of a fraction to be 0. Well, if x was -4, this would be 0. So the domain is, excuse me, all reals except -4. Okay? Now to rationalize, if I had a denominator of 1 or anything over the square root of 2, let's say, I can multiply by the square root of 2 and square root of 2, and that would make 2 in the denominator, no square roots, and the numerator would be the square root of 2. That would be rationalized. But here it's got square root of 5 minus 2. So we have to multiply by something that will get rid of the square root. Well, square root of 5, if we just do square root of 5, that would make that 5, but this would be 2 square roots of 2, and it wouldn't be gone. If I do by minus 2, then square root of 5 times square root of 5 would be 5. That would be gone. But then I'd have minus 2 square roots of 5 and minus 2 square root of 5. I'd still have square roots of 5. But if I use a plus 2, then I'll have the 25, or the square root of 25, which is 5. And then I'd have 2 square roots of 5 and minus 2 square roots of 5, and those would cancel, and then I'd have minus 4. And that would be rationalized. But if I multiply the denominator by this, I have to multiply the numerator by the same thing. And so I'd get 3 times the square root of 5 plus 2. I could distribute that. This turns out to be 1, so it'd be this over 1. So to rationalize, I have to multiply by what's called the conjugate of this. The conjugate to square root of 5 minus 2 would be square root of 5 plus 2. The conjugate of square root of 5 plus 2 would be square root of 5 minus 2. Technically, we're supposed to change the sign on the square root of 5 and not on the 2, but it works this way, so I let it go either way. So a fraction is rationalized, number 6, when there's no square roots, cube roots, any radicals. When no radicals. That doesn't mean like protesters. Radicals are roots. First, second root, third root, fourth root. No radicals in the denominator. Okay. So the domain of f is from 0 to 7. The domain of g is from -2 to 5. If we're going to do the domain of f plus g, we got to be able to put stuff into f and also put the same numbers into g. Well, the only numbers that are in both of these, the intersection, is from 0 to 5. And so that would be the domain of this. It's the overlap of this. One of them goes from 0 to 7 on this interval. The other one goes from -2 to 5. And we need the overlap, so that would be from 0 to 5. It has to be stuff that can go into both f and g. Now, f divided by g, we would do the same thing, except that when we're doing division, again, the denominator can't be 0. So g of x cannot be 0. So it would be the same domain, except that g of x would have to be that turns out to give 0 would have to throw out. Whatever x does that would have to be also removed from the domain. Now, images of the domain, that's a little confusing. If you have your x's, your domain, like 1, 2, 3, or apple or orange or whatever, and they're mapped onto stuff over here in the range, let's say banana and 5 and -1, and that one goes to there, and this one goes to there, and this one goes to there. These are the images, and so they're called the range. What one gets transferred to is called the image of the domain. Okay? So if y equals f of x, then it's a y is by itself, or f of x is by itself. If it's written y equals 2x plus 3, that's explicit. But if it's 2x plus y equals 3, then y is not solved for, and that would be implicit. So this kind of thing is an explicit function, defined explicitly. Okay, 54. Move things out of the way here. 54. We're supposed to now find the domain of this. Well, we've got division. I don't care if the numerator is 0, so x can be 0. But here, I don't want the denominator to be 0. However, x squared is always 0 or more, and if I add 1, it's always more than 0. It's never 0, so I can use all real numbers in this thing, because I can never find any x that'll make x squared plus 1 be 0. Now for this one, same problem. I don't care if the numerator is 0. I just worry about the denominator because there's no division by 0. Is there anything that would make x squared minus 16 equals 0? Well, if I add 16 to both sides, I get x squared equals 16, and then I take the square root. And we have to remember when we take the square root of both sides that we always have to do plus or minus. So the domain would be all reals except 4 or -4. Can't use those two. Any number except 4 or -4. Okay, so now what's the domain of this one? Well, again, the denominator can't be 0. Numerator can be, but not the denominator. But I can't take the square roots of negatives. So I got two things to watch out for. The t minus 4 can be 0, or it can be greater than 0. Now, if I solve for this, I add 4 to both sides. It says t has to be greater than or equal to 4. So on the number line, t would have to be 4 or more, or if you're using the interval notation like that. Now the denominator can't be 0, so 3t minus 21 cannot equal 0. So if I add 21, that says 3t cannot equal 21. If I divide by 3 on both sides, it says t cannot equal 7. Is 7 in here? Yep, so I have to throw it out. So the domain would go from 4 up to 7, including the 4, but not the 7, union, and then from 7 on I could use not 7, but on to infinity. So there is the domain for that. 67. Here's f and g, and we're supposed to find f plus g, so we add these two. Looks like we'd have 5x plus 1. It says subtract them. So f, 3x, minus 2x would be 1x. 4, subtract a negative 3. So let's write this out because some people are going to mess this up. 3x plus 4 minus 2x plus minus 3. So I need to distribute the subtract. So it becomes 3x plus 4 minus 2x plus 3. So 3x minus 2x is 1x. 4 plus 3 is 7. Now it says multiply them. And I know students are going to mess that up. 3x plus 4 times 2x minus 3. And they're going to forget the FOIL. 3x times 2x is 6x squared. 3x times minus 3 is minus 9x. 4 times 2x is plus 8x. So that's minus 1x. And then the 4 times the minus 3 is minus 12. Now divide them. We're just going to write it divided. 3x plus 4 divided by 2x minus 3. Now, if we want to find f plus g of 3, I could put 3 into this, which would be 15 plus 1, 16. Or I could put 3 into this, which would be 9 plus 4, 13, plus g of 3. 2 times 3 is 6 minus 3 is 3. Comes out to be 16. So I could do it either way. I could plug it into where I found it, or just plug 3 into both of these and add the answers. And same thing with the 4. I can put 4 in here, which would be 4 plus 7, which is 11. Or I could put 4 into f. That's 12 plus 4, 16, minus 4 in there would be 8 minus 3 is 5. 16 minus 5 is 11. Now if I got to do f times g of 2, this, when we multiply them, we often make mistakes, but we could do this still here. So 2 squared is 4 times 6, 24 minus 2, 1 times 2 is 2. 24 minus 2 is 22, minus 12 is 10. But we could also put 2 into here, which is 6 plus 4, 10, times, put 2 into here, and that would be 4 minus 3, 1, which is 10. So you can do it either way. And f divided by g of 1, we could put it into here. We get 3 plus 4 is 7 over 1 times 1 is 1 plus 7. Wait a minute. 2 times 1 is 2 minus 3 is minus 1, negative 7. Which is, or I could put the 1 into these two and divide them. And that's basically what I did looking at this. So there's not a second way to do that one very well. Okay? All right. Next one is 79. On 79, we're supposed to do the difference quotient for this. So we do f with the x's replaced with x plus h. So f for replacing the x with x plus h plus 3. This is the f of x plus h put in place of the x's. Minus f of x. Well, that's putting x in place of the x's, so it looks the same. 4x plus 3. And again, I remind you, please put parentheses around this whole thing and that whole thing so we remember to distribute that minus over h. And so we get 4 times x plus 4 times h. And this 4 is not times the 3, but it's plus. Then we have minus 4x and minus 3 when we distribute that minus over h. And as I said, if we have a normal line or parabola or a cubic or something like that, all the non-h terms should cancel. 4x minus 4x plus 3 minus 3. So we have 4h over h, which is 4. Now, the difference quotient is supposed to give us the slope. This has a slope of 4, so it works out. Now, on the test, I expect you to do all this work. Show me that you can do it. Now we have to do it on 89. And the simplifying, they gave you a hint, but let's just do it. Replace the x's with x plus h in this. So we're going to have the square root of x plus h minus 2 minus f of x, which is the square root of x minus 2. Now, since we got this square root, I really don't need the parentheses, but just to emphasize, I would like you to use parentheses, over h. Now, they said rationalize the numerator. Well, once again, rationalizing, you multiply by the, where'd it go here? We did that earlier here. Multiply by the conjugate. If it's a square root and a minus, we multiply the plus one. If it's a plus, then we multiply by the minus. Here we have a minus. We have square roots 2 places, but that doesn't matter. That still works. So this gets kind of lengthy here. We're going to multiply by this thing. And the x plus h, there's nothing to distribute, so we can drop the parentheses. It's going to be x plus h minus 2. Instead of minus here, we're going to go plus square root of x minus 2 times the numerator and the denominator. Now, when we multiply, we take this times that, which is going to lose the square root, so we're going to get the square. We're going to get x plus h minus 2. Then we're going to multiply this times that, which is going to have these two multiplied with a plus. And then we're going to multiply these two. It's going to be the same two things with a minus, so they're going to cancel. And then we multiply the last times the last. That's going to be minus, and it's going to be square root of x minus 2 times square root of x minus 2 is x minus 2. Over, we have an h, and then we have this stuff. Now we're hoping that we get down to just h's again. So we've got a plus x and a minus x. We got a minus 2, and we got minus a minus, which is plus 2. And so that's all going to cancel. And I have h over h times this. The h's will cancel, and I'll be left with 1 over square root of x plus h minus 2 plus the square root of x minus 2. That's all, it all worked out. Okay? 93. Okay, it says figure out what a is. But they tell you if you use 2 for the x, you should get 5. All right, let's use 2 for the x. So we're going to have 2 times 2 to the third plus a times 2 squared plus 4 times 2 minus 5. And it's supposed to come out to equal, when you put 2 in here, when you put 2 into the function, you're supposed to get 5. 2 to the third is 8 times 2, 16, plus 2 squared is 4a. 4 times 2 is 8 minus 5 is supposed to equal 5. 8 minus 5 is 3. 16 plus 3 is 19, so we have 4a plus 19 equals 5. If I subtract 19 from both sides, I get 4a equals negative 14. Yes. Divide by 4 and I get a equal to negative 14 fourths, or negative 7 halves. Okay, a couple of them that are more about the language. Find the function of the area of a rectangle in terms of the length. So we have a rectangle. Let's call this the length, and this the width. And it says the length is twice as long as the width. So this is 2w. Or the width, if the length is twice as long as w, the w is half of the length. Now the area would be just length times width, but that wouldn't be a function in just L. If we did it in w, it'd be 2w times w, which would be the area as a function of w would be 2w squared. But they want it in terms of L. So our correct answer for this one, the area of this rectangle, in terms of L would be L times half L. So that makes a square and a half. Now on 109, they said P, X is the year, and P is the percentage of your income in that year that you spend on healthcare. So it's going to be some kind of percentage like 0.3 or 30% you spend on healthcare, or 0.2 if you only spend 20%, or maybe you only spend 10% or 15%. It could be maybe 0.15. It returns some number like that. And income is dependent on the year, so you're going to get some kind of income, like you might make $30,000 a year, or 70,000, or those of you who become doctors and lawyers might make 100 and something. But anyway, so the income's something like this. P is some kind of percentage. How do you figure out the total amount of dollars you spend on healthcare? Well, it would be this percentage of the income. So it would be P of X times the income that you get in that year. And this is all they wanted you to do, is come up with that. Got it?